All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 80 is on the screen. Let's get started, please. See how you do with that? It's a continuation from what we've been doing on the warm-ups. Focus, please. Once you're done with a warm-up, get a Cornell note ready. You do need a prayer model. We're moving on. And stay with me. Today is going to be a challenging day, but I think it's very doable. So, copy that and go. All right, here we go. Number 1. What'd you get for number 1? Dylan, approximately 6.7. Hands if you got that. Looks about right. Number 2, really quick, I'm going to sketch it up here. My quadratic function goes to the point of origin. Looks like this. It's a parabola. All right. However, when we write our rule, substituting values should look like this. G of x equals negative, parentheses, x minus 3 squared plus 4, which means our parabola is going to end up at a new vertex. Tell your neighbor the new vertex, please. New vertex for that new transformation. All right, new vertex, Joel. 3, 4. So 3, 4, it's going to end up somewhere up here. That is correct. But before we move it, tell your neighbor what this does to the whole function. This negative right there. What does that do to the whole function, everyone? Upside down. So that means our parabola is going to be at that point, but upside down like so. That is correct. All right. Check with your neighbor for the factors of 3a. Factors of 3a. All right. Factors of 3a. JP, what'd you get? So first you divide by 3, so our GCF is 3, and then parentheses, parentheses. What are our other 2 factors? That is correct. So these are my 3 factors. Yeah, GCF was 3, so we're left with x squared minus 2x minus 15, and the rest is history. All right. 3b. Just to go a little bit faster for the sake of time, I multiply 2 times 3. That is 6. And then the 7 down here. So what factors of 6 add up to 7? 6 and 1. So this is 2x squared plus 6x plus 1x plus 3. You group, and the rest is history. So this is x plus 3 and 2x plus 1. Hands if you got that by yourself. All right. However, just to refreshing your noodle with the shortcut method for this one, who remembers the shortcut? Okay, good. You take the leading coefficient. I'm going to make fractions out of these 2 numbers. So, can we simplify this fraction? Yes, that is 1/3, or x plus 3. Can I simplify this fraction? 2 over 1. Let's see. No, that's the least I can simplify it to, so that's why we end up with 2x plus 1. All right, good. Number 4. Process. Is it in standard form? Let's see. 3rd degree, 1st degree, 0th degree. Which one are missing? 2nd. So I'm going to put a box like so. And this one, it is in standard form, so I'm going to set it equal to 0 and solve. Plus 2 plus 2. So this is x equals 2. So we start with 2. Coefficients for this one is 7. 2nd degree, we don't have any, so we put a 0. 1st degree is -6, and for 0 it's 9. Bring down to 7. Let's start. 2 times 7 is 14. Combined, that's 14. 2 times 14 is 28. Combined, that's 22. 2 times 22 is 44. Combined, that's 53 as our remainder. So, we started with a cubic, and now we have this. Tell your neighbor what we have now before Joel passes it to someone. Pass someone, Joel. Let's go. Let's go. That is correct. Yes. All right. And last but not least, let's graph those two lines. Let me get my coordinate plane down here. You got the the x-axis, y-axis. I'm going to start with y equals -4. So we need to look for where y -4 is at, which is down here. And you sketch a straight line going through there. And then in red, I'm going to do x equals -2. -2 is about right there. And a line going straight through that point. Once again, these are known as vertical and horizontal lines. All right, good review, yes? Yes, Mr. Q. All right, copy the agenda for today, please. Warm-up number 80. Today we're moving on to parabolas. You're like, parabolas, aren't we? Have we been doing that, Mr. Q? Yes, but today's going to be a formal introduction, and we're going to get into deriving quadratic equations from parabolas. So copy the agenda, and your home plate for tonight, you have to do at least 4 of these, because you need to get that in your noodle, memorize the process. I'm just giving you a heads up, it's a long process, but it's very doable, okay? Copy that. All right, here we go. Our objective for today, I can derive quadratic equation of a parabola. I can derive a quadratic equation of a parabola. I can derive a quadratic equation of a parabola. So far we know what a quadratic equation are. I mean, what is, because we've been working with those since the probably the 3rd week of the school year. Parabolas, we know what they look like. Those are the graph of the quadratic equations and functions. But today we're going to derive them, and the word derive is to create or to abstract from somewhere, to get something from somewhere. Okay. So today the process, we're going to base it on what we know already in regards to quadratics and parabolas and graphing and such, okay? All right, so once again, a reminder for everyone, tonight's home plate, you need to do at least 4 of these deriving quadratic equations. Why at least 4? Because you need to have it memorized just in case, wink, wink, hint, hint, you walk in and I give you a blank sheet of paper and I ask you to derive a quadratic equation from scratch. All right? So, with that said, in your prayer model, what is a parabola? Once again, put away all electronic devices, ear pods, earbuds, and all that, please, pretty please. I need your full focus. Parabolas, what are they? They are the set of all points equidistant from a line known as a directrix and a focus, which is a point. So, once again, a parabola is formed or is the set of all points equidistant from a line known as a directrix and a point known as a focus. Make sure you use those 2 colors because we're going to be using that throughout. In the examples, we start with a point known as the focus. I'm going to do that in red. And the line right below that in blue known as the directrix. Directrix. Sketch that. Copy that really quick. Now a parabola, I'm going to do that in green, is formed by a bunch of points that are the same distance away from the focus and the directrix. Now, the trick here now, compared to what we did the other day with the circle just went all the way around. But this time, that circle is restricted because now the distance from the focus has to be the same distance from the directrix with all the points that form the parabola. That's why I made this curve that looks something like this. Something like this. So do that in green, please. And of course, we put arrows at the end. All right. So, according to the definition, it says the parabola is formed with equidistant points from the directrix and the focus. So what does that mean, Mr. Q? That means, look up, guys, that between the focus and the directrix, all these points that form the parabola are equidistant. Now, the easiest ones that I can think of that are equidistant is the one in between the directrix and the focus, or if I place one right here. Watch. Look up, please. If I place a point right there, this distance is going to look very similar or equal to that distance. Do you guys see that it looks like a little square right there? Right? Why? Because according to the definition, it's equidistant. Equidistant. And that's what it is. It's a bunch of points, and that's what makes our parabola of all those points that are equidistant from the directrix. Same thing if I place one right here, and so on and so forth. All those are equidistant. Okay? So, any questions as to what a parabola is? Does everybody know how to start a parabola? Yes, we need a focus and a what? And a directrix. Okay. So a non-example. Give us a non-example, Frida. A what? A star. Okay, give me a second. Let me... A star. Okay. Another non-example. Jessica. A heart. Aww. Another non-example. Isabella. Triangle. And one more. Anaya. A what? Said square? Square. There you go. All right. So what makes a parabola a parabola? Hashtag what, guys? What makes a parabola? Equidistant points, yes. Equidistant points. And I'm going to add one more. In order to have equidistant points, we need two things. What two things do we need? Focus and directrix. Yeah, that's what makes a parabola. All right? So far so good, yes? Yes, Mr. Q. All right. So with that said, look up to the screen. Today we're going to be talking about standard form equation of a parabola. Don't copy this. You've already seen this before. Look up to the screen. Have we seen these kind of equations? Yes, but I think we started with one that looked like this, y equals x squared. Is that correct? And then we changed it to what? F of x equals x squared. Have we seen those? And then the transformations, g of x equals a, x squared, blah, 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 blah. Yes? Yeah, all that's familiar. But my question has always been since I was a kid, where does that come from? So I remember when I used to get gifts, they used to give me like radios and stuff. Sometimes I wanted to find out, how does the speaker work? So I used to break the radio so I can see the inside. Does that make sense? Kind of like some of you that tear apart computers and phones and stuff like that, something like that. So today we're going to tear this one apart to see where this quadratic equation comes from, okay? So turn your paper over. We're going to need an entire page. Oh, yes. Turn your paper over. Yes. So title it at the top, Deriving the Quadratic Equation of a Parabola. Now, we're going to start slow. It's going to start accelerating little by little, but this is the process that you're going to study tonight, step by step. Deriving the quadratic equation of a parabola. So in order to create a parabola, we're going to start from the graph. What do we need to create a parabola before we get to the equation? Let's see. What do we need? What do I start with? Tell your neighbor, what would we start with to create a parabola first? What do you guys think? Yeah, a focus. So place a point and label it focus. What else do we need? A line, is that correct? Known as a what? Directrix. So skip like 1 or 2 lines down and draw a blue straight line like so. And we're going to label this directrix. Directrix. All right. So it's building up pretty quick. So what does the definition tell us in regards to parabola? That it's points that are what? Equidistant from the focus to the what? To the directrix. So can you picture the point that's the same distance from these two? Yeah, where will I place that? The fastest one will be right here, is that correct? Yes, Mr. Q. Which means there is a point on the directrix. So now we have 3 points. But do you notice that this distance, this one right here, D1, is the same as D2. Do you guys see that? Yeah? So below that, skip like some lines, and I want you to write D1 is the same as D2. How we doing? Ivan, you good? Okay, good. So, now, do I want it just like that in the air? No, I want it on a coordinate plane. So, check this out. I'm going to get a black straight line going through this middle point between the focus and directrix. Like so. And we're going to label that one X. Which means we need a what? A Y. So draw a straight line down through all 3 points, and that's my Y axis. All right, that's making sense, okay. So, with that said, let's label what we have. So if this is X, look up to the screen, and if this is Y, tell your neighbor the coordinate of this point. What is the coordinate for that point? Yeah, 0, 0. Label that 0, 0. The point above it, the focus, I'm just going to label it 0, P for point. And the point below it, I'm going to label it 0, negative P, since it's below the point of origin. Okay? So far, from 1 to 5, how comfortable are you with that? Yeah, 5, 5, 5. Yeah, we got this. Okay, yeah. So that's plenty of practice. You've been seeing coordinate planes since 5th, 6th grade, so, you know, this is all good. However, we need a parabola. So for the parabola, we need more points. So I'm going to do one more point, and I'm going to put that point somewhere over here. So place a point right there. Just double check that this distance, look up, this distance is the same as or close to that distance, which means we're going to need a point right here too. So that new point, I'm going to label XY, this one, which means I need a coordinate for this one right here. So this one right here, let's see, what's the X value? Well, it's still X. How about the Y value for this one? What is the Y value? What is it? Yeah, negative P. Yes, there it is. And now we can actually sketch half of our parabola. Let's start at the point of origin, going through this point, but as a curve. So curve it. Look how beautiful that looks. My goodness. About some cute merch, yeah? Bam, a shirt. Let's go. What do you think, Jaden? Yeah? All right. So, now, you get the picture. Look up to the screen that if I was to place another point over here on the left side, we would be able to form our parabola. Is that correct? All right, but I'm not going to do that because I want us to focus on this part. Now, check this out. Let me move this focus a little bit further. Focus. Okay, there's our focus. All right, so writing your utensils down, look up to the screen really quick. So this is what I want to show you. We started off with distance 1 equal to distance 2. Okay. If I place another point over here to make our parabola, that means now I'm focusing on this distance. Look up, this distance, and this distance. But what do we know? That still, this distance is the same as this distance. Do you agree with that? Yes? So what am I saying? So we're saying that this is our new distance 1, and this is our new what? Distance 2. Label that, please. If you have highlighters, make sure you highlight that. All right. So we're still in agreement that it doesn't matter which points I use, either these first two and these second two, that the distance are the same, or these new 2 points and new 2 points, and the distances are still the same. Do you agree with that? Yes? All right. So this is what I'm going to do. Writing utensils down, you'll finish copying the part of the process in a little bit. I just need you to focus, okay? Here it goes. Please, pretty please. No writing till the end. I'll show you. I'll give you some time. So right now I'm going to focus on distance 1, but the new distance 1. Look up, this one and this one. Now, how do I find the distance between 2 points? Do we know how to find the distance between 2 points? Yes, Mr. Q. We use the distance formula. Oh, yeah, that's true. Square root x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So which means if I have x sub 2, x sub 1, that means I need 2 points, don't I? And I substitute those values into my formula. Pay attention, please, or you're going to miss it. So I'm looking at the yellow highlighter right here, D1, the new D1, which means what? That this point, the focus, is going to be my first point, so I'm going to label this one x sub 1, y sub 1. So far, so good? That means that this second point over here is my what? X sub 2, y sub 2. So far, so good? So check this out. So I'm going to start slow. I'm going to start with x sub 1, y sub 1. What is x sub 1? 0. What is y sub 1? P. Okay. Next, I need x sub 2, y sub 2. What is x sub 2? X. What is y sub 2? Y. Okay. So, hold on before you copy. Let me elaborate on this. Look up to the screen. So watch. D sub 1. Do we need the 0? No, because it's 0, right? So I'm left with what? X squared plus. What does this mean? It means y minus p times y minus p. So far, so good, yes? All right, so d sub 1 is x squared, and I'm going to distribute this. What is y times y? Y squared. What is y times negative p? Negative py. What is negative p times y? Negative py. And negative p times negative p? Positive p squared. So if I write that in simplified form, it looks like this. x squared plus y squared plus p squared minus 2py. Copy that, please. Ooh-wee. Looks good, right? Let's go. All right, so far so good, yes? All right, so it's doable. Distance formula substituted for 2 points for distance 1. Okay, so writing utensils down, look up to the screen. So I did that for distance 1. Now I'm going to do that for distance 2. So look up, writing utensils down, please. I'm going to write distance 2 right next to, so it's mimicking this. Square root, parentheses, x sub 2 minus x sub 1 squared, plus y sub 2 minus y sub 1 squared, and all that is our distance 2. So I need values to substitute into my formula. All right? Writing utensils down, look up to the screen. So I need, again, x sub 1, x sub 2, and y sub 1, y sub 2. Now, where do I get those from? I can't use this distance. Now I need to use distance 2. So watch. I have this one already labeled, x sub 2, y sub 2. So that means that my first point down here is going to be my x sub 1, y sub 1. Do you guys see that? So I'm going to use this point and this point. So let me go slow. Here we go. I need x sub 1, y sub 1. So what is x sub 1? X. What is y sub 1? Negative what? P. Next, I need x sub 2, y sub 2. What is x sub 2 again? X. What is y sub 2? Y. All right. Now that I have that, here we go. Don't copy that yet. Let me just show you really quick. What is x minus x? 0 squared. And then we have plus y minus p squared is the same as y plus p times y plus p. Do you agree with that so far? All right. We don't need to write the 0. Let's multiply this out. What is y times y? Y squared. What is y times p? Py. What is p times y? Py. And what is p times p? P squared. And all that is our distance 2. And if we simplify that, we end up with y squared plus p squared. Py plus py is what? 2py. And all that is our distance 2. Copy that, please. We did distance 1 for the first distance of the 2 points, simplified all the way. Distance 2 for the 2 points for the distance 2, simplified all the way. Can't combine anything else, so we stop right there. So, look up to the screen. Do you agree then that if we said earlier that distance 1 is the same as distance 2, therefore, square root x squared plus y squared plus p squared minus 2py is equal to what? Square root y squared plus p squared plus 2py. Is that correct? Didn't we say that distance 1 is the same as distance 2? Yes? So that means that if this is distance 1, that should be equal to this. Is that correct? Yes. So copy that really quick. We're going to finish this together. So, once we have it in an equation form like this, we need to isolate x or leave x by itself. So the first thing we need to do is get rid of the square roots. What cancels the square root, guys? A squared. So we need to square both sides. This cancels that. This cancels that. And we're left with x squared plus y squared plus p squared minus 2py equals to y squared plus p squared plus 2py. Okay, we still need to leave x by itself. So look at the left side, look up. What do we need to get rid of? The y squared, the p squared, the negative 2py, so that means I subtract y squared, subtract p squared, and add 2py to leave the x by itself right there. But whatever I do to one side, I do to the other side. Which means this cancels, this cancels, this cancels, this cancels, that cancels. So what do we have left on one side? X squared equals, what do we have on the other side? 4py. And students, this is our standard form equation of a parabola. You're like, what? Yeah, the only thing, notice here, instead of the 4py, we usually use an a, right? Or a coefficient of 1. So for right now, just leave it at that. All right, let's look at from afar what this looks like. Look how beautiful that looks. And for the sake of February, here it goes, here it goes. Aww, look at that. You can make a card out of it. There it is. So tonight, if you want to make it a family math night and get some Valentine's cards going, there you go. You have your process. So, what's your home plate for tonight? You need to memorize this all the way down. That's why you need to do at least 4 of these, or times 4. If you need more, then do more. All right? I'll stop the video right here. Those of you that are joining us via YouTube, enjoy your practice. Make it a family math night. Peace.